Hello everybody, I'm Noah Malakar and my presentation today is going to be on organic LEDs. Thank you for your time. This has been a very, I'm not going to say difficult, but it's certainly been an interesting project. I've definitely learned a lot about the subject of organic LEDs, and they're actually a lot more fascinating than I thought they would be and a lot more complex. So hopefully within this presentation, I'll break it down so it's not such a complex subject and hopefully maybe give you some insight, maybe a little bit of interest on the subject as a whole. With that, let's get started. So something that I like to do to kind of help stay organized is kind of create a little overview of what's going to be discussed in this project. So with that, there's going to be a few goals that hopefully you guys will and gals will be able to kind of explain and take away from this presentation. So hopefully by the end of this presentation, you're going to learn what an organic LED is. You're going to learn why it's organic. Um, you're going to learn kind of the basic layers of an organic LED. So in case you didn't realize, an organic LED kind of has some different layers. So you'll have really just a whole kind of plethora of different layers of this LED that light will shine through. So I don't know, that's just kind of like a little basic thing that I gave, but instead of it just being like a little bulb or anything like that, it's actually about like sheets of different materials stacked on top of each other, each one serving a different purpose. Speaking of materials, you're going to learn a few of the materials that can be used in creating an organic LED. And then you're going to learn kind of some of the pros and cons of organic LEDs because there are some uses that organic LEDs have that are like, oh wow, these are fantastic. These are like the best things since sliced bread. And then there are other aspects of organic LEDs that are really hinder its ability, like standing out in direct sunlight. If you've ever looked down at a phone screen, it's like barely visible. That is kind of an issue that organic LEDs run into a lot of the times. Finally, I'm going to kind of elaborate on some of the industrial applications that organic LEDs could possibly utilize and ways that they can kind of improve manufacturing as a whole, as well as make it more efficient, more cost effective, and also more cool. Um, you'll understand what I mean later in this presentation. So, what is an organic LED for starters? So, organic LEDs are called organic light emitting diodes. And as the name implies, you run electricity through them and they emit light. Um, the reason why they are organic is because we have carbon involved. Now, there's not just going to be like a flat out sheet of carbon within the organic LED because that would be way too easy. Um, but no, actually, it's because within organic LED, it uses a lot of different polymers, compounds, mixtures with different properties that help assist in each phase of an organic LED that contribute to it producing light. Another interesting fact about organic LEDs is that they have many different configurations depending on what you actually want to use the LED for. So let's say you only really need something basic like a general space light or a desk lamp, then you're probably not going to have as many layers. It's probably going to be one solid color. It may or may not be able to vary the color, um, but it's just like a basic layout. Whereas if you have something like a 8K television screen, then you're going to have a lot more layers and different layouts and ways to, you know, change the light color and really make it just a vivid display. So, because organic LEDs have such a wide variety of configurations and compounds and materials that it can use to kind of change the structure, I'm going to focus on just like a broad, basic OLED description. Um, so a basic organic LED has basically 6 layers. And so we have right here is our substrate layer. Um, and this layer is kind of like our foundation. It's what creates the shape of the OLED, and I'll go into more detail with that. Um, above that we have our anode, and our anode kind of acts as like the pool for electrons. It creates that difference. Our conductive layer is a really interesting layer. It kind of interacts with our emissive layer, so these two are buddies. They help produce the light involved with the organic LED. Then we have our cathode, that's what kind of supplies our electricity as a whole, and our seal layer just kind of acts as an umbrella. It kind of keeps the water and other elements out of the organic LED, so that way we don't have to really worry about it getting damaged or destroyed while it's being used. Once again, as the name implies, the reason why organic LEDs are organic LEDs is because they utilize organic material, mainly carbon, within their compounds and mixtures. And of course, these amounts and these materials will vary depending on the end use of the OLED, which I'll mention some of the following later in this course. Researching the materials for the OLEDs was a very difficult process, so please don't expect everything, but hopefully there's going to be enough info for you guys to work with. So the substrate layer is our first layer of the organic LED, and this layer is probably one of the most important, even though that it does not really have the most important materials. So the way an organic LED works, first of all, is that when it emits light, the light shines downwards. So think of this big yellow arrow that I'm drawing is the light. So whenever you're looking at like an OLED display or an organic LED in general, you are looking at the substrate layer. That is the layer that light shines through. So the substrate layer is always transparent. It can either be made out of glass, plastic, or even a thin metal film. And obviously, if it's see-through, then the metal film is really, really, really thin. And not only is this layer important for your ability to see through it, but it's also important of determining other factors such as the shape of the OLED. It can determine whether or not it's flexible. It'll determine whether it's waterproof, depending on how well the substrate is sealed with the seal layer. So it just has a lot of different practicality uses. No. But it is a very important layer. It is what every other layer builds upon. The next layer of the organic LED is our anode. So as I mentioned earlier with the flow of electrons flowing down through our OLED, so let's take a minute to examine this further. So this green arrow I drew here is the direction in which electrons would like to flow. So we have all these little electrons coming through. But the thing is that we have this negatively charged cathode, and the electrons, they want to seek a positive charge. So what the anode does is that the anode provides that positive charge. it's not electronically charged. And so all of these little electrons want to move down towards the anode. So the anode creates the pull for the electricity within the OLED and also the circuit. I may interchange those words, but we're speaking of organic LEDs. So another interesting fact about the anode is that the anode is completely transparent. The anode is really a film of what is known as indium tin oxide. Right here, that allows the electrons to flow through the circuit. So I'm going to create like our little battery here. We have our negative charge, and then the anode's connected to the positive part of our battery. And so why specifically indium tin oxide? Like, why not just use a sheet of aluminum or copper or silver or any other type of metal? Well, the reason why we use indium tin oxide is because of its properties. So for one, it is highly, highly conductive, and two, it is invisible. You can't see it. It allows light to flow through it. So how do we get indium tin oxide? Where is it from? How do we source it? How do we process it? So indium is mined, and it's typically found mixed in with zinc, iron, lead, and copper ores. It's not really found on its own. And it's separated from these different ores, and then it's mixed with a solvent and an oxidizing agent to create indium oxide. And this indium oxide has the properties that are conductive and invisible. Well, then if indium oxide by itself is conductive and invisible, where's the tin come into play? What does the tin do? So the tin, what it does is it stabilizes it. So we have this indium oxide, but it doesn't really stay put. It doesn't harden. It doesn't really have that ionic bond. So what tin oxide does is it's the stabilizing agent. So tin is mined from cassiterite, and then it's put through a process of like in a smelt furnace pretty much. And then once it's separated, it's mixed with a solvent and oxidizing agent to create tin oxide. And along with being, stable, it's non-toxic, it's ductile, so it'll, it stretches, it pulls, it bends, it's malleable, and it's stable. And once again, not only is it a good bonding agent, but it also has its own conductivity. So when the two are mixed together, it creates this indium tin oxide, and it's what allows the anode to really attract those electrons. Another interesting fact about the anode is that since it's a coating, it can be applied through spray coating, or it can even be applied with additive manufacturing processes such as inkjet printing, depending on the shape of the organic LED. So the next layer of organic LED is the conductive layer. So the conductive layer is this little layer right here. The big arrow is pointing into it, this yellow arrow is pointing to it. And its job is probably one of the most crucial within the organic LED. And that being said, it is also probably one of the most confusing and varying layers within an organic LED, just because of the way of how many different configurations there can be of the conductive layer. Sometimes you can have multiple layers, such as a hole transport layer or an electron transport layer, and other times you just have the conductive layer. There are many different materials that can be used to create the conductive layer, but the most common one that you will see is polyaniline, otherwise known as PANI. And this material is utilized for many different reasons. For one, it is highly conductive, and it really allows electrons to not only move freely, but also to combine and be pulled apart freely. On top of that, polyaniline is relatively cheap to produce, and it's pretty easy to synthesize in a lab. So with polyaniline, it really gives the conductive layer its purpose. So with that said, how does this layer actually work? Why is it so important? With that, I'm going to explain this little lesson right here. So let's set up our organic LED with our circuit. So we have our anode, we have our cathode. All right, so the way this works is that we have electrons going into our LED from the battery or our power source. And the cathode is all negatively charged, and these charges want to move down towards our relatively positively charged anode. Well, as they're moving down, right on the edge between the conductive layer and our emissive layer, these negative particles combine with these positively charged holes, is how they refer to them as in the industry. And so whenever they mix or combine, they release light, which is what you see. Now you may be asking, well, they're combined, they're stable, right? Well, sort of. Because of the nature of the conductive layer, the pull of the anode is stronger than the bonds that are formed between these negatively charged and positively charged particles. So the electricity ends up being pulled towards the anode anyways, and then back out towards the battery to complete the circuit. Well, then what happens to these positive charges? Where do they go? They obviously don't disappear, right? Well, they move back upwards. They move towards the edge of our conductive layer and the emissive layer. And that's why organic LEDs can continue running and producing light. It's because that these particles of energy are just constantly combining and then splitting apart. And the combining is what creates the light. Alongside with the conductive layer, the other most important layer in creating light from an organic LED is the emissive layer. So as I mentioned previously, the emissive layer likes to collect these electrons. It likes to store them as they continue working their way down. And as it collides with the conductive layer, they combine and then they produce light. So, what color of light exactly does it produce? Well, that really depends on the polymer or the compound used in order to create the emissive layer. So some examples of compounds and polymers would be hydroxyquinoline aluminum, you can use polyfluorine, you can use triphenylamine as different ways to sort of create an emissive layer that can produce different types of light. On top of producing different colors of light, the emissive layer can also be set up in a large variety of configurations. So if you look closely down over in here in the OLED device structures, so our basic organic LED is going to be this one right here. This is just kind of the the 6 different layers, and it just probably produces a white light or like a soft yellow light depending on the structure. So it's pretty basic. There's not much going into that. Now, as we get more advanced, we may have one that can sort of vary the brightness without necessarily having to vary the amount of electricity as much going through in order to create the brightness. And then over here, what we can see is kind of what's used in a lot of smartphones and television screens, where we have our RGB emitters that illuminate in different amounts in order to create the light that we see in pictures. Speaking of different displays, there are also 2 distinct ways in which companies are starting to create OLED displays. So over here with this phone is probably the most recognized and common way of creating a screen, which is you have all these little red, green, and blue dots that are tightly packed within one another, And whenever, you know, a picture is desired to be created, every single one of these little pixels, is what they call them, will illuminate at different rates in order to create the right color of light that your eye recognizes as the picture. Um, as screen technology is getting more and more advanced, and different companies are trying to figure out different ways to really pack in these pixels and make a screen super high definition, clear, easy to read, we're starting to see more configurations like this picture down here. And while this may look like a daunting task, all this really is we create a white light emitted from every single pixel, and then using a series of different filter layers and different electricity applied and all these other little factors, we can create pretty much any color with every single pixel involved. This allows us to create some super high definition, vibrant displays. And so we're going to start seeing more and more of these types of configurations coming out in the future. So the cathode is the back of the organic LED. And the cathode serves the purpose as being the electron source. So as it connects from the battery, all these electrons go and immediately are dispersed across the cathode. This is the first real layer that the electrons meet. And so the cathode's job is to just be a conductor. It can often be made out of a metal like aluminum, or it can be made transparent out of indium tin oxide, depending on whether or not you want something that just has a single plane of view like a computer screen, or if you want something where light emits maybe both sides like a light fixture, where you can kind of have like a soft glow up here and then emit light down below. Um, the cathode is very similar to the anode pretty much. In fact, it could be identical. As I mentioned earlier, depending on the end use, its main job is just to conduct electricity. So the final layer of an organic LED is the seal layer. And this layer, much like the substrate layer, is designed to just kind of case the OLED and just protect it from the outside elements. It's often made from basic materials such as glass, plastic. It could be metal. We don't often see metal being used. But overall, it's just a way to kind of shield the OLED from outside elements. The seal layer can be transparent or it can be opaque, once again depending on the end use, whether this is just a one-way screen or a one-way light, or if you want like a transparent display, or maybe a light fixture where light is emitted on both sides as to create like a more warm and ambient environment. So now that we've gotten through like what an organic LED is and how it actually works, now we get to the question of why even use an organic LED? We have other ways of lighting. We have regular LEDs which provide ample lighting. And as far as displays, we have liquid crystal displays, LCDs. Why would we need an OLED? So to answer that question, we have to look at some of the benefits of organic LEDs. So an organic LED is what we call a diffused light source. And what that means is that the light doesn't produce a lot of glare. It's not that powerful, but it just covers a vast area. And therefore, because it doesn't have as much glare, you can kind of place it wherever you want, and it won't really bother your eyes. So this means you can have the light much closer to a material, say, that you're trying to inspect. And so because it doesn't have to be as bright, you can have it close to the material. You don't have to use as much electricity in order to power it. As well as being more efficient, they can be very thin and they can even be flexible. depending on what materials make up the organic LED. This can allow you to place it in intricate corners or geometries and create different fixtures that are pleasing to see. Um, Organic LEDs are easy to shape. Once again, as I mentioned with the fixtures, you can really put them anywhere. Um, on top of that, you can even make them transparent. So if there's something that, you know, maybe you want some information display, but you also want to be able to see what's going on, maybe behind the screen, an organic LED would be great at being able to complete both of those tasks. Now, organic LEDs, while they do have their benefits, they certainly aren't without their flaws. Some limitations that organic LEDs may have is that, for one, they are a bit higher cost to produce than their competitor, which is the LCD, the liquid crystal display. Um, Also, the way an organic LED functions is that since the individual pixels are what creating the light with the emissive layer, whenever you want a brighter display, you have to put more power into the display. Whereas in a liquid crystal display, you just have a backlight. And so you have a constant light and you just change the way the shutters work. Um, this really limits organic LEDs, especially outdoors with direct sunlight, as you can see in the picture of this Nokia phone. Um, Oftentimes, OLED displays are very difficult to see outdoors. Finally, another very major concern is that organic LEDs decay over time. Because the material is organic and it decays pretty rapidly, so does the display. Usually, the average lifetime of an organic LED display is around like 3 to 5 years before it decreases to around 70% of its original brightness, which still isn't bad, but it certainly can improve, and researchers are looking more into how to improve uh, the life expectancy of an OLED over time. Um, Another important thing I forgot to mention about efficiency is that um, OLED displays, while they are certainly efficient, um, whenever you need to produce brighter colors like white or some shades of gray and different vibrant or other vibrant colors, there needs to be more power drawn in order to create these colors. So as you change the screen color, your power consumption is also affected. So now knowing the advantages and disadvantages of organic LEDs, how do we apply them into an industrial setting? Well, there are certainly a few uses that organic LEDs can serve in an industrial facility. For one, factory lighting. So overhead lights, organic LEDs can make them a little less overbearing, a little bit better to deal with, and still producing a bright light, but creating an environment where the lights won't necessarily give workers headaches. Um, it can also be used in inspection booths because the light is diffused and can be pretty much placed around any material that may need to be inspected without producing much of a glare. Organic LEDs would be very practical in use for inspecting. Um, as a lot of factories transition to becoming more digital with different computer displays, OLEDs make pretty good computer displays. They produce vivid colors with a pretty pretty good efficiency. Um, Another interesting concept that OLEDs can fulfill is the idea of a clear display. So let's say you want a board meeting in a room that may like overlook a factory floor, and you want, you know, people coming in who are interested in the company that you're trying to pitch to. If you really want to impress them, you can give your lecture or your speech on a board that's, you know, interactive, where you can see all the content, but you can also see like the factory floor. They can see what's going on behind the screen. This can also be good for inspections, whereas you can have a part like in an inspection box, and if it detects any flaws, it can actually circle the flaw in real time over the spot it's at in the material. So there are a lot of interesting concepts that could be done with a clear display. Another concept that we're seeing unfold quite literally more and more is the idea of a folding phone screen. And so as workers, sometimes we have to be mobile, running around completing different tasks and writing down important dates and times and trying to keep track of different info. As we continue to digitize, having a folding display rather than a few different books and materials could be beneficial to the workplace experience overall, especially manufacturing. So as these technologies improve, we're going to start seeing them more and more in our industrial use, and it would be a good idea to take advantage and use them to their full potential. And OLEDs certainly help us do that. Once again, I'd like to thank you for taking some time out of your day and learning about the fascinating subject of organic LEDs. Hopefully at this point you can recognize what an organic LED is, how it works, and even some ways that it can be applied in the manufacturing world. I hope you have a blessed morning, evening, afternoon, doesn't matter. Be safe, always wear your seatbelt.